Hello, this is Saxon Math, Course 1, Lesson 107. It's called Area of Complex Shapes. Before in Lesson 103, we actually did the perimeter. So we've done perimeter of complex shapes, and that's where you're going from one point and going all the way around. What's the distance around it? Area is all of that space on the inside. So we're looking at all this space in here, and we're also looking at additional space in this position here. So this is like having two different shapes that are combined, where you have two rectangles basically. And when you have those two rectangles combined, you can find the area of the whole surface or that shape by just simply adding them together. So remember, the perimeter was just simply the adding all the sides up. We did that in lesson 103. In this lesson 107, we're looking at the area of complex shapes. So that's all of the space that's made up on the inside. All you have to do is divide the shape into two or more parts. So for example, this complex shape, you can see they divided it up into two rectangles, one here and one here. Once you find the area of each part of those, all you have to do is add the total of each part. So this piece right here is 28 centimeters squared, and this piece is 6 centimeters squared. And you add those two pieces together and you end up with a total, which is considered the area of the complex shape. So this would make up this whole area inside. It would be this entire space would be 34 centimeters squared. All you need to remember though, when you're using formulas, in this case, area of a rectangle is length times width, and the area of a triangle is base times height divided by 2, or sometimes it's referred this way, 1/2 base times height. Sometimes it's also written like that. And then you just need to make sure you label it with square units. So let's try this one. There's a number of ways you can look at it. You can look at it like, hey, here's a shape right here. Or you could look at it like this. You could also look at it like, hey, here's another way to divide these complex shapes up. Now, it's up to you what you want to decide. If I'm going to go with this vertical space, so I'm going to make this space here and this space here, two different rectangles. So once I use those two rectangles, I can break it down by, looks like in this case, the area of this one is length times width, which is, in this case, I can see that it's 6 centimeters times 3 centimeters. And in this case, that's 18 centimeters squared. So I know that this space right here is 18 centimeters squared. This space here is also the same formula. I'm going to use area equals length times width. So because it's length times width, I need to find out what the length is, and it looks like I don't know for sure. But that's this distance right here. I also know that I already know what this distance is because I see that 3. So we're drawing on another, when we were looking at your previous lesson 103 in perimeter, we could determine what each of these lengths would be. If this is 7 all the way across and this one is 3, that means this is 4 centimeters. So that means I now have a box, a square. Basically, this is 4 centimeters times 4 centimeters. So that means the area of this would be 16 centimeters squared. So the area of this box is 16 centimeters squared, and the area of this rectangle is 18 centimeters squared. So now I just have to add those together. 18 plus 16 ends up being 1434 centimeters squared. That would be the complex shape, the whole thing, all the way across on the inside. Okay, what if we broke this down? Let me break it down like this, though. What if we went this direction? Well, in that case, it would be 3 times, that's 3 centimeters, times, we would take 4 minus the 6, which is 2 centimeters. And that would end up being 6 centimeters squared for the area of that rectangle. This rectangle would be 7 centimeters times 4 centimeters. And that would end up being 28 centimeters squared. 2 centimeters makes it squared. So then you have that 28 plus the 6, which makes 34 centimeters squared. Same thing that we had before. You're still going to end up with the same answer depending on what, doesn't really matter what direction you look at it. You could also look at this in an entirely another way where you could say, hey, what's this negative space over here? This space that's unknown. We could determine that this is, if you take this 6 times this 7, that's this whole area on the inside here. So all the area inside here. We could take that 7 centimeters times 6 centimeters, which equals 42 centimeters squared. And then we could subtract. We could actually subtract that. I don't want to get you too confused here. This isn't something, I'm not trying to confuse you, but you can take away this space because this isn't really part of the complex shape. But if we were to extend this side out and extend this side out, this now just becomes a rectangle of 42 centimeters squared. But remember, this is not in as part of that. But what is this length right here? Well, this length is 2 centimeters. How do I know that? Because this side is 6 and this side here is 4. 4 plus 2 makes 6. I also know that this side right here is 4 centimeters. So if I did that 4 times 2, that makes this 8 centimeters squared. So that value right there is 8. If I subtracted 8 centimeters squared, my answer is still going to be centimeters squared in this, by the way. But 42 minus 8 makes 34. And that space, same as we had before, same space. It's just we're using a negative space now. So there's 3 different ways you can look at that complex shape. All right, go ahead and do this. You'll need a piece of paper, but if you have a side that's 10 inches, one side that's 3, an unknown side, we don't know what this side is. We also don't know what this side is. We have a 4-inch side and an 8-inch side. So go ahead and answer, what's the area? That means how much space is taken up by all of these on the inside here. So what's the area on the inside of this complex shape? Well, what do we need to do? It doesn't matter what you decide. If you decided to go this direction, you could do that. Or if you wanted to divide this into another part like this, you could do that. It doesn't really matter. Let's do it this way first. So if you have 10 minus 4, I know that this side is going to be 6 inches here. And I know that this 8 all the way up vertical here, we've got 8 here minus this 3 vertical here, means that this piece is 5 inches. Now that I know all the sides, now I can determine what this is. The area of this one is length times width. And the length in this case is 6 inches for this piece right here, from here to here. That's 6 inches. And then it's times this 3 inches. Okay, so now I know the area of this rectangle as 18 inches squared. Okay, now I also need to determine this one. This one is the same formula, area equals length times width. And this one would be the area equals 8 inches times, looks like 4 inches is right there. Okay, And that means that the area of this particular rectangle is 32 inches squared. So now I have to take that 32 inches squared plus 18 inches squared. And when I add those up, that's the total. So this would be 10, carry that would be 50 inches squared. It's the value of the inside of this complex shape. Okay. Now I don't want to confuse you, but here's another way to look at it. Some of you may have done it this way. And in that case, you just work it out again, length times width. The area of this rectangle equals length times width. This would be 10 inches times, in this case, 3 inches. So I know the area of this rectangle is 30 inches squared. This one, I don't know the length just yet, but I know that this is 8 inches and this is 3 inches. So that means this is 5 inches. So that means the length is 5 inches. Usually the length is the longer one. Doesn't really matter though. And the width is 4 inches. So now I have area of this space is 20 inches squared. So now I just take that 30 inches plus the 20 inches squared, and it ends up being 50 inches squared, just like we had before. All right, let's try this one. It's a little trickier, but you just need to use the formula for the area of a triangle. If you don't remember the formula for the area of a triangle, it's 1/2 base times height, or it's base times height divided by 2. Okay, go ahead and do it. All right, the only way you can really split this one up, you can't take this corner and go all the way over here. You need to use the information that we have here. We need to know that this piece is 14. The only way this really works is for this to be a nice straight 90-degree line from this base right here. This has to be a nice straight 90-degree line. That's really the only way we can split this one up. So if you didn't do that, then it may have messed up your answer. But the reason why we need to do that is because we need to transfer this 10 centimeter line down to this side so that we know how much this piece is. And we already know what this piece is. We can see that it's 6 centimeters because of the other side over there. So because of it, you can tell that in this case, this is 6 centimeters, and this one is going to be 4 centimeters. So I know now I've got area equals length times width. And in this case, the length is going to be 10 centimeters and the width is 6 centimeters. So this rectangle, the area equals 60 centimeters squared for the rectangle. For the area of the triangle, area equals 1/2 base times height is what I like to use for my equation. That means the area equals 1/2, and the base in this case looks like it's, well, I'm just going to use 4, well, I'll use 6 centimeters. It doesn't really matter, but then I have times 4 centimeters. So one of them has to be the base, one of them has to be the height. So now if I figure that out, I know that 1/2 of 6 is 3 centimeters, and 3 centimeters times 4 makes 12 centimeters, and it has to be squared. So the area of the triangle is 12 centimeters squared. The area of this rectangle that we created out of this complex shape was 60 centimeters squared. You need to add the two together. 60 plus 12 is 72, and make sure you label it 72 centimeters squared for the inside space. All right, if you did well on that, now you've got your quiz on Go Formative. Just go back in there and make sure that you divide each one of these up however you see fit. You know, if you want to divide this one in this way, or if you just decided to divide it this way, it's up to you really. It doesn't matter. Same with number 2, you can divide it this direction, or you can divide it this direction. It's up to you. For number 3, you could divide it this way, or you could divide it up this way. You just need to determine, remember when you determine these, you need to determine what the area of this space is and what the area of this space is. If you're going to divide it this way, you need to find the area of this space and the area of this space. If you divided it this way, you need the area of this space and the area of this space. On the triangle, or sorry, the one that has a triangle space in it, it has to be, this is the only way you can divide this one. So then you need to find the area of this space and the area of that space. Okay, try to complete that by midnight tonight, and we'll see you guys tomorrow. Thanks for watching.